Let's go ahead and take a look at the configuration of 802.1x from the perspective of ISE. First off, we'll take a look at the digital certificates that will need to be installed on ISE. Remember, not only the management perspective, using TLS is going to benefit from that digital certificate, but also our authentication. Anytime we want to use tunneled EAP, if we wanted to do an SSL or TLS handshake to tunnel that EAP, we'd want the digital certificate there. We'll configure identity sources, and that is where the user is going to exist. They could live in an internal database within the identity services engine. So this could be the only user container in the environment if you preferred to do it that way. A lot of companies that have been up and running for a while already have an existing infrastructure based on Active Directory. So we might implement ISE and then point ISE with a connector to Active Directory and just leverage their user database. We'll configure network devices. Remember that all the devices that authenticate need to be defined on both sides. So if I've got a switch that plans on implementing 802.1x, and I've got an ICE cube here off to the right, I want to make sure that the components within my ICE cube know about this Radius client, just like the Radius client needs to know about the Radius server. That's where we just pointed to the IP address of the other device, and then we make sure that the password's right on both sides. Remember that our Cisco devices are going to look at the destination IP address of that ICE server and then determine how to get there based on the routing table. If routing changes, we could be sourcing our traffic, our Radius queries, through a different interface, which could cause them to fail. The ICE server doesn't know that that particular IP is going to be a AAA client. So just keep that in the back of your mind. I don't know what your environment looks like, but if you've got multiple paths or something that could occur, a lot of times this happens when you're doing a software update or something in the middle of the night. We do that changeover we do the software update, we reboot that switch, there's a topology change. Now our authentication requests are coming from a new IP, and they could fail because of it. So before you freak out, when you're in that troubleshooting process, just think about it. Are my Radius queries coming from the right source IP address? And we can also test the queries. You've got your supplicant out here, and you could log in, but there's things that could go wrong with the way that this supplicant's being authenticated. If I'm having problems with AAA, I'd just like to split the pie right down the middle and start troubleshooting from the switch or the authenticator back towards the AAA server. Because if that doesn't work, nothing's going to work. Validate that this is up and running. It's easy. There's a handful of commands available depending on which device you're on. And once we know the backend is functional, let's come back and check out the client side. So ISE uses digital certificates for a few different things. Of course, we're going to use it for the HTTPS connections, which is used for not only web management by the administrators, but also a guest portal. Remember, when devices attach to the network, maybe we've got a list of previously identified devices. So idea being that if we've got corporate devices that we've seen before, that we've provisioned, that maybe we've hardened, we could say we trust those devices to a certain level. That's something that we want to see. You can actually authenticate the device. This is called, not to go too far down a dirt road here, EAP chaining. You think chain of just one thing being kind of linked to another? What we're doing there is we're taking the user identity, and then we're also taking the machine identity. And we can do an authentication of both, right? So maybe this is what we want to see for all of our equipment. Somebody goes out on their lunch break, they buy a brand new tablet, they come back into the office. They can authenticate to a guest portal. Why? Because they can authenticate through our real portal. When they get there, they'll use HTTPS to hit a web page. That web page they'll authenticate in securely over HTTPS. And once they punch in their credentials, depending on how you've got it set up, you could, if you chose to, support BYOD with device registration. So the idea is somebody authenticates to the guest portal, they go ahead and they do an HTTPS handshake to that portal to authenticate, and then not only are their credentials being passed securely, but we're also making sure that that device can now be registered by the user, which makes it a little bit easier for those of us that have to work on the technical side supporting all this. The more things the users can do securely, the better, right? So what you want to think about this is you go, okay, well, I've got my ICE server. My ICE server is going to be behind the firewall. So when we think about deploying identity certificates, you go, okay, well, I'm going to go to VeriSign or Thought or Entrust or whoever, and I'm going to get a certificate for the outside of my firewall because people are coming in via remote access VPN. Okay, sure. But what happens when you hit ISE? If you need to do any type of enrollment with ISE, maybe you want to enroll and set up a device like we were just saying, the device that's being enrolled isn't going to trust an internal CA server. Right? A lot of times for our internal servers, KVMs, out-of-band management appliances, we'll use self-signed certificates or certificates that come from a private CA. That's fine if we control all the endpoints, right? Because the supplicant that the administrator is going to be using needs to trust this CA server. On enterprise components, no problem, right? We can install that root certificate and say that it should be trusted. The problem comes back when we do BYOD, because the device that somebody picked up on their lunch break isn't going to trust our digital certificate. Why? Because they don't trust our CA server. So even though ISE could be configured with private IP addressing and it's never touching the public internet, we still might need a digital certificate on it that comes from a public CA server. And the idea there is that BYOD type devices are going to believe that certificate and they can authenticate securely. Remember that ISE can use EAP methods which use certificate-based server authentication. So protected EAP. You can use a username and password. You don't have to have a digital certificate, but the server side has a certificate. That's easy. I've got one server and I've got 500 users, right? That's easy to deploy. We can also identify ISE in a distributed ISE environment. That's what we call that ISE cube, where we take different services of ISE and we run them on different systems. This allows us to connect and not only achieve greater resiliency, but we can also gain greater throughput. Just because we cluster those together in our capabilities in terms of how many authentication requests we can process, how many users we can support, that starts to climb. So the CA root certificate, as far as getting it onto ISE, we can use it to authenticate clients in EAP methods that use a client-based certificate. That is, if I've got an internal CA server and I'm going to issue identity certificates to my supplicants, ISE needs to believe that this server is a trusted root. Because if not, the identity certificates that these users are presenting wouldn't appear to be valid. So by default, ISE comes with self-signed digital certificate just to get it up and deployed. Typically, we want to replace that with the certificate that comes from a trusted CA server. So here we're taking a look at the way that certificates can be used. Remember that when you first connect to ISE, ISE can authenticate itself. And this is with server-side certificate-based authentication. Those words just go together. It describes exactly what it's doing. The server side is going to present an identity certificate, assuming that the supplicant trusts this root. That's why we've got to pay for it. So that when you buy a laptop or tablet from Best Buy, it's automatically going to work with their firewall. Why? Because both parties went to the CA server, spent money for manual verification. At that point, we know that the ISE server is who we think it is. So we've got this TLS connection, or perhaps we've got a PEAP or EAP fast connection. This gives us the ability to tunnel, so I can do EAP with MS Chat version 2. This is challenge handshake. This is old. This is crackable. But because it's going inside of this protected tunnel, it's going to be secure. Now, in order to get that tunnel up, we've got to have that server-side certificate. So how hard is this to deploy? Really not too bad. We can go ahead and import a new certificate into the certificate store. And we can say what it should be trusted for. Should it be trusted for authentication with ISE, meaning our user identity certificate is going to come there? Should it be trusted for client authentication in syslog? We can do crazy stuff where we'll actually build an IPsec tunnel and pass syslog traffic through it. Syslog is typically not encrypted. But you can do man in the middle from an attacker perspective and intercept syslog messages. It's UDP based, so you don't get acknowledgments, so we can drop some of them if we wanted to, if we had access to that traffic. Just showing you here that we can actually leverage digital certificates to secure it. We can use authentication of Cisco services, and we can also validate certificate extensions if we choose to. So what we're generating here is called a CSR, or Certificate Signing Request. And whenever you want a certificate, you have to ask a CA server to give you one, right? So what it really comes down to is you've got a device, could be a router, could be a firewall, could be an ISE server. And this device needs to create an RSA key pair, which consists of a public key, which everyone's allowed to know, and a private key, which no one is allowed to know. Once you create that key pair, this is just a 2048-bit key. It looks like a big chunk of just crazy characters. But what we want to do is send that over to the CA server. And we put this in a specific format. There's a public key cryptography standard, which talks about the encoding and formatting of these types of messages. And we leverage the PKCS to define a standards-based CSR, just a certificate signing request, which basically says, hey, CA server, I want to link this public key, which is just a string of characters, with this identity. Could be an email address, fully qualified domain name, city, state, organizational unit. It's kind of like a department. We go, hey, here's all this real-world stuff that goes with a crazy string of characters. The CA administrator verifies that information and then pushes back to the user an identity certificate. This is at X.509 version 3. Also standardized within, we talk about public key cryptography standards and SSL and how all this came from Netscape. This is how it's worked for many, many years. The enrollment process is just like this. You've got a certificate signing request, it's your public key and identity, you give it to the CA, they validate that information, they give you your identity certificate. What is it? Just a fancy container for your public key. But when we give it to other people, they know that that public key absolutely represents us. And then if they've done the same thing in advance, if they've checked into that CA server and gotten a certificate, we just exchange these certificates like you or I could show each other our driver's license, and we go, okay, cool, we've authenticated. So here we're taking a look at the different identity sources. Just real quick, as I mentioned before, our identity sources, we could create user accounts directly within ISE. That's fine. That means ISE is our one-stop shop to do everything that we need. Alternatively, if you've got an existing infrastructure, which is the case for a lot of customers, we go, okay, we can hook into that. And they go, are you sure? And I say, are you using LDAP? Are you using Radius? Are you using Active Directory? Are you using RSA secure tokens? Are you using anything based on SAML v2? Are you using anything that supports ODBC? If so, we can tie into that and we can validate who the users are. So I throw Active Directory around just because in my personal travels, this is what I've come across the most, but I have integrated it into other solutions. There's some crazy stuff out there that you may come across from time to time. So if you've got to interact with, say, OpenLDAP or something, you've got the capabilities here to do that. So when we talk about configuring the internal identity source, this is where we create user accounts. Typically, it's not that scalable. So what we tend to focus on sometimes are guest accounts, as well as our MAB solution for, and again, that's our MAC authentication bypass. We use this user endpoint database, and the idea is that it doesn't require an external server. Again, not ideal for large scalability, but a fantastic configuration alternative when we're setting things up in the lab or when we're trying to do things in just a small scale to test it. The users and endpoints are basically members of identity groups, and the user accounts have various attributes. One of them, of course, being mandatory password. If you look at things like EAP-TLS or PEEP-TLS, TLS, think SSL, think digital certificates. Because they're certificates, you don't have to use a password. Why? Because we've got a certificate to authenticate you. The internal database doesn't support EAP-TLS or PEEP-TLS, but when you tie back into AD or you tie back into other components out there, or even directly into CA systems, we can support those. Endpoint devices are going to be identified based on the MAC address, which again can be spoofed. It's not the most secure, but part of our policy can push down a very restrictive access control list for any MAB devices. So here we are within the ISE interface under network access and then under identities. And on our endpoints, we can come in here and add endpoints. And the first option that they give you is to define the MAC address. We can also import MAC addresses from files. We can also import them from LDAP if you have an external registry. here we show the ability to configure an external identity source. So the way that this happens, again, we've got the supplicant all the way on the left. We've got the authenticator in the middle. That's our door guy who says, hey, who goes there? And then we've got our AAA server on the back end. Now, the AAA server might be AAA servers, not just in the context of IceCube, but also in the context of multiple dimensions to this. And that is, we first throw our credentials into a AAA server. And again, this is the end of our Radius communication. We terminated the Radius session, we passed our credentials there, and we go, clearly, this must be the device that knows that username and password. Nope, all they're doing is just relaying those credentials once again to a backend database. Again, this is used all over the place, but it's important to understand this process for any time we want to do troubleshooting. Again, I tend to cut the pie or divide and conquer. If you can log into ICE, ICE has got some nice interfaces for troubleshooting, so we can test and just make sure things are working on the back end. A lot of times, this is where I'll tie into AD, so I can test, and I can say, does ICE talk to AD successfully? Yes, okay, cool. Is my authenticator talking to ICE successfully? Again, this is going to be Radius. This is going to be AD or LDAP. Over here, this is going to be EAP. So we've got different configuration requirements. We've got different protocols, different port numbers that are in use the whole way along. If you've got any type of access list or any type of filtering, those could potentially bother this communication. So things we want to watch for. All we're doing here is connecting to Active Directory. So we can specify the join point name as well as the Active Directory domain. And then what happens, we'll submit, it'll come back and prompt us for a user account that's got the ability to do administration of AD, type in those credentials, and then this device, an ICE appliance, will appear within Active Directory users and computers. So when we talk about identity source sequencing, this is just saying, hey, when someone sends us our credentials, this is the first place I want to check. And oh, well, if they weren't found there, go ahead and check in the second place. I don't really want two places for users to exist. I want everything to exist in one place. But we've done a merger, we're in the middle of a migration, and it's not pretty, but this is what we've got. Fair enough. We can just define the sequence here, and we can move from one to the other, which can be pretty handy. Here they are just creating an identity source sequence. You give it a name, a description. On the left-hand side, we've got the available authentication sources, and the ones that we want to select, we'll just highlight, move over, and then we can reorder these by moving them up and down the list. And here we are defining our Radius clients. When we define a network device, we're saying here's the name of the device, here's the IP address, here's a profile to associate with it, here's some information about the device, and then typically a password. What's going to happen is when devices connect and they pass us the authentication details, we're going to look at it and we're going to evaluate it in a certain way. So what you see defining this is called a policy set, and it's basically what I just like to call an if decision. You're saying, hey, ICE, if you see traffic, he's like, yeah, and it looks like this, he's like, yeah, go evaluate it in this way. I go, however, if you see traffic and it looks like this, wireless, evaluate it like this and like this. So we're using more secure, potentially authentication methods over a less secure network. Makes sense, right? And here are what we're showing is allowed protocols. And the way that this is work, it's like, hey, if somebody comes in, they authenticate through MAB, then we're going to try to find their MAC address in this database called internal users that lives in ICE. If they're sending us credentials via 802.1x, well, we're not going to find their username in ICE. We want to point to Active Directory. And if that doesn't work out, we're going to try this other server called LDAP1. And again, our authentication policy is where we go to look up the user. The authorization policy is what actually controls the user's access level, thus the term authorization, right? So a lot of times what we do is we say if group. What we're doing here is looking at the member of attribute, many times, within Active Directory. So yes, you've got a user account, sure, that's your password, but you're a member of certain groups. that detail will be sent back to ISE. So again, here's our supplicant, here's the authenticator, here's ISE, here's Active Directory, right? So here come our credentials. They get relayed over to ISE. ISE isn't sure, he asks AD. And again, what we're doing is sending a username and password. That can be returned, and it's like, yeah, that username and password is actually member of IT admins. And that means something to us. Active Directory group membership would directly correlate with your job role, which would directly correlate with the level of access that you should have within the environment, which would actually correlate with the sensitivity of your data. You know, beyond just using an ACL, we can define a MACsec policy, which says all traffic coming from this user should be encrypted. Nothing should cross the wire clear text. So here you see your default policy suite. This is what everybody hits out of the box. And this suffices for the majority of 802.1x deployments. We can set a default policy. We have, hopefully, it works across the board for everything. And then once we find exceptions that it doesn't work for, well, we can create policy sets that would match those exceptions. Here's how the policy set works under the hood. Essentially, you've got your authentication method, .1x, MAB, or WebAuth. Once you try to pass those credentials along, they're going to be relayed via radius. And that radius is going to hit these if conditions, which basically get us to an identity store. Like we said, it could be internal, like those MAC addresses, external, like AD, which is going to lead us to some results. They're going to pass or fail. That's going to tie into our authorization policy. So let's say that they do pass. Well, we can get to if conditions. If conditions can be based on all sorts of cool things. Authorization profiles, posture assessments, profiling, again, the type of device, and even guest services. So we can do a series of different types of checks, not only who are you, what group are you a member of. We can think about, okay, how secure is the endpoint? Has it been patched? No, it hasn't. Well, let's work on remediation. As we go on, we can create pretty elaborate rule sets that describe what happens when a user connects to the environment. And again, their status or state could change. That's why we've got that change of authorization. So here we are exploring the ISE authentication policy. And again, this is really just if conditions. We say, hey, if, and we can look at different parameters. We can look at EAP type. We can look at digital certificate serial numbers. We can look at all sorts of parameters. It could be a single if condition, or it could be a compound condition that says we want to see a serial number that exists in the certificate that's this exact serial number, as well as an EAP type of TLS. What's that mean? Well, here's your result. Say, if we see this style of connectivity, then auth like this. If we see this style of connectivity, then auth like that. So just an if-then relationship, and it gets a name. So identity sources used to validate credentials, used to retrieve group information. They can be grouped into identity source sequences. And then the Cisco ISE internal identity sources can be used for both users and endpoints, where, of course, typically we use an external for the users. Here, what they're showing you are authentication policies. It starts off on the left. We see MAB. We see .1x. We see the conditions, wired or wireless, wired or wireless. And again, what we can try for are what's the style of connectivity? And then where do we authenticate the users? Internal endpoints versus all user ID stores. That's going to be a grouping that would contain multiple servers. The default identity source sequence suffices for the majority of .1x. Again, maybe you've had some type of merger, you've got some type of weird exception. We can create the if and then solution for that exception here. Here's a flowchart showing you the basic ISE authorization. And you'll see this follows a lot of the same components that we talked about previously. An authentication policy, an authorization policy, and then we can look further and consider things like posture, profiling, and guest services. Here's a bit of a flowchart, and it's just showing you what basically is going to lead us through that authorization process. It's first going to start off with a name. Whenever we build our policy, we'll have a set of conditions. This is our if, and then the resulting permissions in a form of an authorization profile. This is the then. So we can say things like, hey, if you see that the posture is not that great because antivirus isn't up to snuff, ... pause for effect, right? He's like, okay, then perform this authorization profile. And these are all some of the parameters that we can push down. So authorization policies got various building blocks. When we define things within ISE, we can come back and leverage them from drop-down boxes. So when we talk about employee access, contractor access, etc., these authorization profiles will define what it is that we want to do. In this case, we want to push down a downloadable ACL to the switch. Here's the name of the ACL. Here's the particular entries of the ACL. And again, it'll just be pushed down and applied on that particular device.